guys, if you haven't seen my video on the Golden Devs channel, you might want to check it out before following this one, since it builds off the premises I set up there. And for those of you who are coming from there, I'm truly sorry that I split the tutorial, but as I said, needed views. As established in the previous video, our next goal would be to procedurally generate the terrain itself alongside the obstacles that we are creating. First step I'll make towards doing so is to make our tile more of an empty tile, so I'm going to make it gray, and then create a new tile prefab for the ground that keeps the vibrant green of the original tiles. Once we are inside the code, it'd be a wise idea to create a new GameObject variable for us to spawn our proper tiles with, which I will equip to our script real quick. After that, we can start working on making the ground procedurally generate. Think about it logically, the function should be rather similar to our previously built functions, except that we also need to check adjacent tiles for tiles. If you would like, you can also build a tolerance range for the distance. It can be from existing tiles, if you want to add dashing between empty spaces, for example. While I'm going to keep it at 1, I'll make a variable for it so it's still easier to add in if I decide to increase the checking distance for whatever reason in future projects, and to display how one might do it. Because we're going to be doing things a little bit differently now, I'm going to get rid of the code that calls the function to generate the obstacles. And then because the function to generate the ground tiles is rather similar to the obstacle generation, I'll also copy the code for it and change up the name so that we can get started with generating tiles. First major change needed is that we need to make sure that there are other tiles within the tolerance range, or right next to it. To do that, after we check to see if there's anything in the tile that was randomly chosen, we then need to check if the tiles around it have an occupied tile for the range that we set earlier. Doing this is rather simple. If, like me, you're going to check adjacent tiles, you need to make 2 separate loops where you start from the negative tile range at the end of the positive range, +1. Because we're checking for if it's under, you can also just add an equal sign. If you want to do diagonals, you just need to nest them in each other. Next, we make a bool outside asking if the ground is in range, and then inside the for loops, the code is as simple as checking if the tile is currently selected is occupied, then saying that the ground is in range if it is. Then, we nest the instantiation code inside another if statement, so that if at the end of it, a piece of ground is indeed in range, it will create the tile in its designated location. Now, I'm going to call this function in the awake function and try it out in-game. If you hit play, you should notice that no tiles are actually spawning, and right now that is actually a good sign, because we don't have any tiles down in the first place. Also, if you're getting an out of range exception, I will be addressing that in a second. To create the first tile that all the others will branch off of, we can just make a simple function to make one. However, you may want to edit these later to fit your game better. For now though, I'll make a new function called createFirstTile. Inside, I will write int x equals tiles.count divided by 2, and int y equals tilesx.count divided by 2. Then GameObject new tile equals instantiate ground tile at new vector 3 at xy with just transform.rotation, since we're not doing anything with rotations. Tiles xy.getComponent tilescript.occupied equals true, and then new tile.transform.setParent tiles xy.transform, because I like to keep the hierarchy clean. Now we just have to call the function in the awake function, and it should work. As you can see, a tile is now spawning in the middle, but also, despite having the code, you might notice that we are getting little to no tiles spawned, especially if you have a smaller grid at the moment. If you look inside the console, then you can see why this is happening, in the form of a null reference exception. Basically, what happens is that when it is checking around the tile, when the tile is at the edge of the range, it can end up looking for a negative number, or one outside the range. And because those tiles are non-existent, it gives you an error, breaking the entire code. Thankfully, the code isn't too bad, even though it was a pain to figure out because of one tiny insignificant little error I made when doing a copy-paste. After creating the ground in range variable, I will introduce 4 new variables: x left range, x right range, y dip range, and y height range. If the x left range plus our randomly generated x is under 0, Then we subtract x left range plus x because it'll give us the negative number that it's under by. And in case you forgot how math works, when you subtract a negative number, it's like adding it as a positive number. Pushing it back to whatever number will keep it at 0 and above. Duplicate this and switch it to y dip range, making sure that you switch all the variables to y ones, so that way you don't end up spending an entire hour trying to figure out what went wrong and if your math is messed up. Next, you check if x right range plus x is greater than tiles.count minus 1, or you could just make it greater than or equal to. If it passes the range, then x right range plus equals tiles.count minus 1 minus x right range plus x, and the range should be all good. Just duplicate that and replace all the x variables for y ones. I'll never forget the pain, trouble, and headache caused by this one little mistake. And then, where you reference the tiles.count, just make sure to add x or something there, so that way it looks for the specific set of tiles. So you get the y range instead of the x one. While I was writing the script, I realized the better way to make sure you're not attempting to check out of range, but out of laziness, I'll let you figure that out. Now that we did that, we can go back into Unity and it should work properly now. The next task we have to do is make it spawn obstacles again, but this time around, we need to make sure that they find a tile that is unoccupied by another obstacle, and it has a ground tile under it, so I don't have to mess with the code too much. I'm just going to keep my occupied thing the same name, so I'm just going to make a new variable called hasObstacles. But to be honest, the variable names on this thing should probably be changed in the future when you use it. Since we are making obstacles again, I will continue our work in the original obstacle spawning script. The first thing that needs to be done is to change the occupied variable to hasObstacle. Now we need to check if the tile has a ground tile on it. For a reason I will demonstrate shortly, I'm going to put the current code inside another if statement, asking if tiles x, y is currently occupied by a tile. Since that is the bool that we are using to tell if the other ground tiles that the space is occupied, it'll work just fine for our new case right here. If we put the code in the awake function once more and load up Unity, we should see that the trees are spawning again. But out of personal preference and not wanting to restrict the space too much, I want to give trees the ability to spawn on the tiles right next to the currently existing tiles by creating a new tile under itself. To do this, I'll make a new function called checkSpecificTile. If we take a step back and think, in this function we need to A, check if the tile is available because of the other tiles around it, then if it is, we need to spawn the tile, and then we need to tell the first function whether or not the tile is available to make a new one in. And before any of that happens, we need to import what coordinates we wish to check. Given this information, the first thing I will do is turn this into a bool so that way we can call it and use it as a boolean. And then I'll copy part of the code using the procedural generation of the tiles to check the tile and spawn it. However, we also need to add the return to it, which is rather easy. Next, we need to import the tile that we are trying to check. Out of personal preference, with working with sendMessage functions, I'm going to make it a vector 2, and then split up the dimensions. Now that that is done, we basically just copied the function from the random generation. For simplicity's sake, it would prove wise to adapt the generate_ground_tiles function to use this new function, instead of keeping all the code inside of it. After we load up Unity, we should be able to see that this little thing should be working, being most noticeable if you have a lower amount of tile spawning. Now, the real reason I actually wanted to do it was for the big obstacles, because they would need a larger open space. It'll make it easier for them to find it. We need to give the big obstacle function the same sort of changes we did for the normal ones. First, I'm going to create a new variable called hasGround to check if we have ground underneath, and then we need to make it check for the ground, which we can pretty much just create a new else if statement after the one checking if the spot we're looking for is already taken by another obstacle. Since there is another obstacle there, we can't spawn it there. Then, if it has ground, we put the normal instantiation code inside another if statement asking if it has ground under it. Although there will be a little issue if it finds available ground, but not all the tiles have ground under it. To fix this, you could theoretically add our check specific tile function. But on the edge case that it found a tile on the top right of an object and starts spawning at the tiles from the bottom left, we'd end up missing the first few tiles or so from spawning. Because of this contingency, we need to make a new function that just force places new tiles, like the function that makes a tile in the center of the grid. In my case, I'll call it createSpecificTile, once again taking in vector2position as its parameter. It's going to do a lot of the same thing as the checking variant, so I'm going to copy it, and then remove some of its code, namely the code that asks if there are tiles nearby. Now we just add it to the area where we're setting all the tiles to be occupied, and because it still asks if there's a tile under it, we don't need to worry about it spawning unnecessary tiles. Then, if it doesn't have the tiles, then we can do a scan through all the tiles and use checkSpecificTile on it inside an if statement, saying that we now have ground, and then duplicate the previous instantiation's if statement. Then we should all be good to go. Just call the function in the awake function once more, and after opening Unity, our rock should spawn once more. This will be the end of this tutorial. I'm hoping that this will be a good starting point for your works. Maybe you'll add different biomes, or maybe use this to generate rooms. The floor is yours, and the only limit is your creativity and coding knowledge. If you were hoping for a little more out of this, or something more complex, the point of my tutorial was only to be a starting point. As part of my nature, I don't like doing all the work for other people, but I'm sure some of you guys out there could do some great stuff with this. See ya!